Hello, I'm going to be showing you guys my code and circuitry for my robot BloomBeam, which is an LED robotic that provides light for hydroponics. It uses a rotary switch to decide either 14, 16, or 18 hours, and then also a PAR sensor to adjust the LED brightness. There's also a servo motor that uses that's being attached to this arm to go 90 degrees to 0 degrees to simulate sunlight movement. So it'll be moving from left to right over the course of the 14, 16, or 18 hours. On the flow chart here, real quick, you can see what's going to be happening, how it starts off. It checks to see what hour cycle length we have chosen. Then it's going to read our PIR sensor throughout the day to continuously update the LED brightness. This keeps running for that cycle. Once 14, 16, or 18 hours is up, it'll turn off the LEDs in the servo motor, wait for 24 hours to pass, and then automatically start again. What's happening in the code is that I'm simulating each second to be an hour. So I have a bunch of global variables here at the start. You can see some of the pins being set here. And I'll just keep scrolling down as we go. Here's the setup, and then here's our actual loop of the code running. So again, I'm simulating every second to be an hour, and as it runs, it will be updating information to the monitor here so you can see what's happening. Here's the initial setup of when it first turns on, and then here's where the cycle is actually running. You can see that it'll be checking if I make any adjustments to the rotary switch, and then same for the servo position as it automatically gets adjusted, and you'll see that movement as it's running. The LED brightness gets adjusted depending on where the photoresistor is being set, and then the cycle here every hour is being updated with information. So I'll go ahead and get it started so you can start seeing the simulation. Right now, the rotary switch is set to the position for 14 hours. Every hour you see gets updated with where it's at. You can see the servo motor here very slowly moving. It's going to be moving over the course of the 14 hours. Let's say if I switch to 18 hours now, you can see it readjusts and goes a lot slower and is going to be losing much less degrees. I'll go ahead and put it at 16 so you can see that it readjusts again for 16 hours. At the end of each day, it prints out a little information of what day it was and how many hours or what the hours was set to. Then it'll wait automatically for 24 hours to pass before going to the next day and starting all over again by itself. So this system essentially never gets turned off. Here you can see the time. So right now we're at 18 seconds. So we're just waiting for that to hit 24 for the next day to begin. For this second day, I'm going to go ahead and play around with the photoresistor to simulate what would be happening to the LEDs as the day is happening. Any ambient light or changes to the LEDs would be being adjusted by the PAR sensor or the photoresistor in this case. So if I go over the 450, you'll see that the LEDs actually begin to dim, and that's being read or printed out here in the monitor. Same for if I go the opposite way, if I'm under 350, in this case, they get brighter and will go up to the brightness of 255. If they're in between 350 and 450, they hit the desired brightness and get readjusted back to 165, which is the desired brightness that they want to be. The code continuously runs again for 24 hours, so this will just keep going day after day. There's a bunch of things for fail-safe that are being updated or that I've updated in the code. So like if I can adjust this at any time without it breaking. Same for the lights. This doesn't read until the next day has begun. So that's pretty much it. Thank you very much.